are picking up on 5B, and we are looking at this extreme value theorem, okay? Remember the extreme value theorem, if f is continuous on a closed interval, then f has both a maximum and a minimum on the given interval, okay? With this example, for each function, justify or explain why the EVT can be applied or why it does not apply on the given interval. So we already looked at A. We ran into a continuity problem because of a vertical asymptote, right? Okay, B. G of x equals e to the x minus 2 plus 1.
Is e to the x. Yeah.
Do that again.
It'd be, for you, it'd be this way. Or is it this way?
The second one.
The second one. Okay.
So when I think of e to the x, it's a log function. So e to the x is like that right there. Okay? What's the minus 2 and plus 1 do to it? Move it right 2 and up 1. So,
EVT applies because it's continuous and different.
okay, now,
On the interval.
and that's the thing, specifically, and we don't have to talk differentiable on this one, remember? I know, we want to, but we don't have to. But, continuous, is it continuous there? For negative 5 to 5? Yeah, okay, so we can say that g of x is continuous, so for all reals, so EVT applies. G of x is continuous for all reals. So EVT applies on negative 5 less than or equal to x less than or equal to 5. Okay, start looking at C when you're ready. With h of x is x times square root of x plus 2.
It's not continuous.
Why?
The thing under the square root. I couldn't tell you what it is, but I do remember that.
Okay. What do we know about values under a square root? Because I agree, that is the big issue here. They have to be positive, right? So what we know here is that because there's x plus 2 under the square root, x plus 2 has to be positive. So greater than or equal to 0, which means x has to be greater than or equal to negative 2. So to the left of negative 2, what does this graph probably not do? Well, it probably doesn't exist. Okay, so it's not, and here's the key. What interval are we talking about? Negative 6 to 6. And you could throw this in the calculator to kind of verify, you know, as we're working with this, but based on the fact that h of x, it's continuous for x greater than or equal to negative 2, but that means EVT cannot apply from negative 6 to 6 because it needs the whole thing. And I honestly don't know what this graph looks like off the top of my head because you throw in that x out front and I'm not sure what that x does. Oh, is this like a swoosh?
It doesn't really swoosh at all, but it's not a straight line.
Okay. Kind of a Nike, just not as much swoosh down there. Okay. But here's the deal. It probably starts around negative 2, doesn't it? Okay. So.
Literally, do it. Literally, Nike. It's not Nike, it's just do it. It's just Nike.
Since h of x is only continuous for x greater than or equal to negative 2. Okay. EVT does not apply on negative 6 less than or equal to x less than or equal to 6. If that interval was different, would EVT apply?
Yep.
Yeah. It's all dependent on what that interval is and where we're looking. Okay. At the bottom, let's give you a brief moment to finish writing that. Okay. At the bottom of this page, before we turn to the next page, there's definition of critical number or critical value. And I will say, those are words you've heard me say at times, because I throw them out forgetting that we haven't technically gone over them yet. I don't know. Honestly, I'll be, critical numbers, critical values are a big part of having to deal with derivatives. And so I guess I kind of find it weird that this stuff that's in Unit 5 comes at the end of everything we're doing, because I feel like the mins and maxes, the derivatives, those are a big thing that with critical numbers and everything. So, but you've heard me mention the idea of critical numbers, okay? But I'm going to actually teach it now. So, a critical number or critical value of a function is an x value, so x equals c, in the domain of f, such that either the derivative equals 0 or the derivative does not exist. More often than not, it's a derivative equals 0. Okay, so when we talk about, I've mentioned this before, when we talk about finding our extrema, our mins and maxes, I always think take the derivative, set it equal to 0. Okay, I just forget that you don't know that yet. So if x of c is a critical point, then c comma f of c is called if it's a critical value, then it's a critical point when you put it in the ordered pair. Okay. Theorems. Relative or local extrema, same idea, right, can only occur at a critical value on an open interval. We're talking a relative or local extrema. They occur on an open interval. So in other words, we're not talking at the endpoints. They occur within the interval is what that's saying. Okay. Absolute extrema must occur at a critical number or at an endpoint. So we talked a little bit yesterday about the difference between having those extrema on the inside versus having them at endpoints. And that actually probably explains a detail that I was confused about yesterday. So, okay, relative and local extrema occur at critical values. Absolute, so those are just specific relative extrema, they can occur at a critical number or at an endpoint, which is why if you're given an endpoint or interval, we always have to check the endpoints, and that's what we're getting ready to do, because that talks to us about candidates test. Okay, we're going to look on this next page of using the candidates test to determine what is the absolute extrema. Like, okay, we have a list of 3 different values that are extrema. What is the absolute without looking at a graph? And so we'll do the candidates test, which basically we're going to find each of our critical values, where extrema might be, and then we're going to find the y values to decide which one is the absolute. Okay, so candidates test. Let's try these. Okay, our directions ask us to find the absolute extrema of the function on the given interval, provided the EVT is applicable. If not, justify why. So, on A, is EVT applicable? What?
Polynomials.
It's polynomial, -1 to 2. I know I'm not writing anything out with that. That's just kind of a self-brain check, like, okay, is EVT good? EVT is good on this one. So, we're being asked to find the absolute extrema, which means we need to start by finding our derivative, because that's how we're going to find our critical values. So, it's a nice derivative, right?
Yeah.
F prime of x is?
What if yours is minus 6x plus 9?
Good? Yeah. Set the derivative equal to 0 to find your critical values. While I'm here, Can I go ahead and factor a GCF out?
Yeah.
If I factor that 3 out, what do I have?
8x. Minus 2x.
And I just went ahead and took that 3 out because it's going to make, makes my numbers a little bit smaller to work with. Now what?
Right, 3 out.
I already divided the 3 out.
I mean, I guess that's 0.
Irrelevant. Waste of time. I mean, you can, but it's fine to just sit there too.
Oh.
Do we need to factor?
Yeah, I'm sure.
How are we going to factor?
PAC. Well, you like easy.
Guess and check, because PAC takes two.
That's what I'm doing. I'm
You
guessing
see.
and checking
I'm
it out.
trying.
It's going rough.
Well, okay, so product of AC is your official method, right? All else fails, product of AC. Now, I am never against guess and check. What I will say on this one,
For some reason, that doesn't even exist.
okay, it does. The problem with this one is 8x squared. Does it have only one option? No, it has
Like 7,
2 options, right? 8x squared could break into what?
4, 2, 4,
4x and 2x, or 8x and x. What about the 3? What's it break into?
3 and 1.
That has to be 3 and 1, doesn't it? And meet me in product of AC if that's your, or slip and slide.
I forgot about slip and slide.
Huh?
So I don't think we know slip and slide.
I mentioned it, didn't I?
We've run
We
over it, but I
know
always
it,
forget.
but we don't know it.
I mentioned it just to kind of demonstrate it. But
Used to it is.
okay, so here's the deal, guys. I need my middle term to be 2. So, for instance, like this is where, if I wanted to say 8 and 1, well, then I'm going to have my outsides are 8, my insides are 3. That's going to give me 5 or 11, depending on signs. What if I make 1 and 8? Outside's 1, inside's 24. That's not going to give me 2.
It has to be 4 and 2.
So it has to be a combination 4 and 2. Insides 4, or outsides 4, insides 6?
Yeah.
That can make it work to get -2, can't it? So, 4x, 2x. If it multiplies me -3, one's negative, one's positive. -2x means I need -6x and +4x. Okay. If you did slip and slide or product of AC, did you get the same answer?
Yeah.
That's the key there, right? Okay. How do we do this then? Okay, set each factor equal to 0. Does 3 matter?
No.
No. And this is where I never divided 3 out like Doug suggested, but I'm just not going to do anything with it. It's just going to sit there. So I'm going to set 4x minus 3 equal to 0 and 2x plus 1 equals 0. We get critical values of 3/4 and -1/2. Okay. So 3/4 and -1/2 represent extrema. Okay, they are most likely mins and maxes. Which is which, what's what, we don't necessarily know. But we were specifically asked to find absolute extrema. Okay, so on a given interval. So when we start talking about candidates test,
It's D, right?
Candidates.
but it's CAN.
D-I-D-I-D.
Oh, I did have to. There we go. Okay.
Candidates.
Sorry.
Who does candy date?
There's a reason I'm a math teacher, folks. But yet that's a word in math, but I can't spell it. But okay. So the candidates test is we're going to test our critical values and our endpoints. So basically I'm going to set up an XY chart. Okay. And I'm going to put each of those values on there. Now, I don't know that it has to, but I tend to go in order. So that means -1's going to be first. 2's going to be second. Or last, I mean. So -1, -1/2, 3/4, and 2. I want to know the y values. Or I said y, what I really should say is f of x, I guess, if you want to get technical.
Does that mean you have to put it all into the big equation?
We do. But
Use calculator.
Oh,
what is the purpose of the calculator on this problem? Not to graph it and cheat and get your answers that way, but to...
Put it in Y1 and then
Yeah.
use Y1.
Ooh. We're using the calculator to get our y values. That's the whole point of the calculator here. Now, Doug does have a point. Can you type this equation into y1 and then take turns doing y1 of -1, of -1/2, so on and so forth?
Yep.
You can.
Where do you find the y's again? What button is it?
Try like alpha F4.
Yeah.
I'm like, it's over that way. And if it's not alpha F4, try one around it.
wait, how do you do it?
Yeah.
Y1.
And then put parentheses.
Okay.
And put your value in parentheses.
Okay.
Oh, sweet.
Are we getting it? I mean, I could pull up the Elmo and demonstrate on my calculator, but
I got it.
or I know I sometimes will plug it into the first one and then copy that down and then just go and change the values, but that's even probably that's more than this, so
That's a big fraction. 19/4. Wait till you get to the next one. Whoa.
I don't have fraction answers, I have decimal answers.
4.75 and
Oh.
-3.26.
That's a big answer too. Did anyone get
Put it in the calculator decimal.
I'm not sure. Make sure.
Okay. I heard Doug say you plug in -1, you get 0.
Yep.
You
Negative
plug in -1/2, you get
4.75.
I have 4.75, which would also is that the 19/4 I heard.
Mhm.
I definitely.
And then negative
3/4.
-3.06.
25.
Is that what it is?
Yes.
Okay. And 2 is 36.
I didn't get derivative.
The original.
Yeah, no, I put in derivative.
There's the problem.
I got -14 for the first answer.
Okay. No. You are plugging into the original problem every time. Okay. So, and notice I did say f of x, not f prime of x. That would be your clue there. But, okay. Now, our question is find the absolute extrema. So on this interval, we have 2 endpoints and we have 2 critical points. Those critical points are mins or maxes, most likely. Absolute means we want the highest and the lowest. So,
3/4 and 2.
what is my max value?
2. Max of
36.
36 at
Oh.
What is my minimum?
0.
-3.
Oh,
Negative 3.0625?
That's it.
That's it.
Those problems are cool.
Okay.
I'm just waiting for something to get a lot more difficult. Yeah,
Throw me
that's what
off.
I'm waiting.
We're going to throw in some trig. How do you feel about that?
And you know.
I mean, there's your more difficult. So I'm getting ready to throw in trig on the next one. Okay, let's move. You ready? Are we good?
Yeah.
Okay. So B. G of x is x minus 2 sine x on the interval 0 to 2 pi. I guess we better talk real quick. EVT, what do you think?
Yeah.
Yeah.
Yeah, you've got sine, you've got x. Those are things that are good, so. Okay. G prime of x is
1 minus 2
2 cosine.
cosine x.
The derivative sign is cosine, so you just keep the negative sign the same, correct?
Yep.
Okay. We're going to set it equal to 0. How do you feel if I add 2 cosine x over?
When does cosine x? Oh.
What is cosine x equal to?
Divide by 2. And exactly, when does cosine x equal 1/2 on the interval 0 to 2 pi? Now, this is calc. Radians are going to be the more expected answer. Unless there's reason that they should throw in degrees.
Pi over 3.
5 over 3 and 5 pi.
Oh, what did you say? See?
Are you with me?
I just mentally drew the triangle in my head.
There you go. And this is where
How are you using that?
pi over 6, pi over 4, pi over 3, sine, cosine. So I know this is 1/2, so that's 1/2. So pi over 3 now. We're looking for when it's positive 1/2. All students take calculus. We need a quadrant 1 answer,
And a quadrant 4.
so pi over 3, and we need a quadrant 4 answer. So what is the pi over 3 angle down here? And here's the deal. If this is 2 pi over 3, so this is 6 pi, or 2 pi, this is 6 pi over 3, then one before it is going to be 5 pi over 3. Okay? To each their own. I heard other people saying, oh, I did this, I did this, I did this. Find a way that works for you, right? Okay. Candidates test. We're going to have x and we're going to have g of x. What are the values we're working with?
0 and 2 pi.
0 and 2 pi and?
Pi over 3. 5.
Okay. You can do the calculator, I guess, can't you?
Yep.
I was cosine of 0 is 1. 1 minus 2 is... Oh, and then I ended up going, I have decimal answers on the chart. Wait a minute, what? Oh, I plugged in, okay, Hannah, I just stole your idea and I just plugged into the derivative instead of the original.
I didn't realize I even did that. I thought I plugged into the original, and so I looked and I said,
Then you couldn't figure out why you're getting them all wrong, yeah. Don't forget to go into the original. I just about screwed that up. And I do have decimal answers here, so since it is a calculator problem, you are justified to give decimal answers.
Oh yeah, it is giving them the decimals.
Because of the pi.
Yeah, your calculator is not going to give you a radian. I mean, it's a radian, but it's decimals. Your calculator is not going to give it to you like with square roots or anything.
Yeah.
Okay. You get some values for me?
ah.
With 0 is 0.
Yeah.
Yeah.
Welcome to that.
And pi over 3 is negative 0.6849.
5 pi over 3 is 6.968. Uh, 2 pi is 6.2. Are you in radians or degrees?
You need to be in radians if you're inputting radians.
I'm in radians.
Mhm.
How would you use it?
If we are inputting radians,
I'm looking at the wrong one.
Good at math.
I was looking at 5 pi over 3. I was like, that's not what I got. There we go.
okay, what do we have here?
Mins and, well, it's the numbers, right?
Your-
So max would be
pi over 3.
Max would be 6.968. And min would be negative 0.685. Why didn't you say like the pi over 3 and 5 pi over 3?
Because when you're talking about extrema value, those are the y values. They are located at pi over 3 and 5 pi over 3. Now, in all honesty, could you give the ordered pair? Possibly, but you have to be careful there. Okay?
It could be like a multiple choice thing.
Yeah.
I feel like that's
It
what
could be.
AP Chem would try to do to us.
Okay. C, and I may start giving you some of these values so that we're not just waiting on the time, but we're going to talk the math at least. Are we ready?
Are we doing all 5 of these?
Yeah, we are, but just because there's practice of other skills here that I want. So C, sine squared x minus cosine x. Do we think EVT applies?
Yes.
Yes. Yeah.
It's sines and cosines. It should. Okay. So that means we're going to find derivative. What is the derivative of sine squared? So derivative of sine to the second, or the derivative of something to the second power, is 2 sine x to the first times the derivative of sine x, which is cosine x. Are you with me there? So because you're thinking of this as sine x to the second.
I thought it was so smart to write the whole thing out.
Yeah, me too.
Okay, you're thinking of sine x to the second. So bring the 2 out front, subtract 1. And then times the derivative of sine x. So there's your cosine x. Minus, what's the derivative of cosine x?
Negative sine x.
Plus.
Negative sine x is going to become plus sine x. Okay. Set it equal to 0. 2 sine x cosine x plus sine x equals 0.
Divide 2.
What'd you say?
Divide 2.
I can't divide the 2 unless I want to put a fraction in front of sine, which is absolutely yuck.
Subtract the sine.
Yeah, you
Factor
can
out a
factor out the sign.
Let's go for factor out of sine.
I should know.
Factor out of sine x, it's a GCF. And then in the parentheses, I'm left with
2 cosine x plus 1. Does that equal one of the 1 things?
No.
maybe, I don't know.
Oh no,
No,
because
so-
the 2 squared.
So now I have
Dang it.
sine x times 2 cosine x plus 1 equals 0. Set each factor
Equal to
0.
equal to 0.
Mm.
So I'm going to set sine x equal to 0, and I'm going to set 2 cosine x plus 1 equal to 0. So we're going to be asking ourselves, where does sine x equal 0, and where does...
Cosine x equals negative 100.
Okay.
0 and it's a 0 and pi over.
Okay.
Or 2 pi over 3.
Now,
Oh, the interval.
Alright.
so check your interval. When does sine equal 0? And that happens at 0 and at...
2 pi.
well,
3 pi over 2, right?
sine happens at every pi. 0, 1 pi, 2 pi, 3 pi, 4
That's
pi.
what I meant.
Because of my interval, I just need to say
0 and pi.
0 and pi. I don't need to say 2 pi. Cosine. Didn't we just do 1/2?
But the positive.
But we did positive, yes?
So now
So right here, it's pi over 3, but now we need the other 2 quadrants, don't we? So if this is pi over 3, then this is 2 pi over 3, because this is 3 pi over 3, and that makes this one 4 pi over 3. Are you with me there?
Yeah.
Okay, so 2 pi over 3 and 4 pi over 3? Okay. Candidates test. We're looking for our absolute. We're going to do 0, 2 pi over 3. I just had to pause and think. Is 4 pi over 3 in our interval?
Yes.
And it is. I'm just saying I had to pause and think because 3 pi over 2 would be right here, wouldn't it?
Mm-hmm.
So 4 pi over 3 is good. We didn't address
So
that.
it's 2 pi over 3 pi. And then 4 pi over 3?
Yep. Okay.
And then 3 pi.
What?
Are we all on the same wavelength here of annoyed at ourselves? I'm annoyed at myself. So we actually have 5 pieces to test, yes? Can I save us some time?
Yeah.
Yep.
Negative 1, 1.25, 1, 1.25, 1.
Oh.
Well, we have an absolute min at -1.
You're taking the easy one?
Yep. And then what?
Absolute min.
And that's it.
Negative.
Absolute min at negative 1.
You don't have an absolute max.
Yeah.
Actually, I have it as we do. Because they are the same. Because they are both the same.
Earlier, yesterday.
It is.
Which question now?
The one about is there an absolute max if it's a sine graph? Because they're always just going to be at the same one.
Well, this is sine and cosine. But still.
And my gut was to say no.
Yeah.
Well, maybe I was wrong. I was going on the fly. You have to give me credit there.
It's
I was
okay.
going off of my gut, like, that's my thought. Obviously, I might have been wrong. It's on recording now, so.
It's hard to do.
But what are we trying to figure out how to put in the calculator?
Sine squared. Oh, it's
You
like
could
a
just-
fun little, it looks like teeth.
You should be able to just, I'm trying to think.
I actually got it.
So sine x, I think honestly, if you just do sine x, close your parentheses and put the squared outside, that works. I think your options on the calculator,
You did that the Rick. There is no 2.
because your calculator actually puts the parentheses is like that. The other option is to do parentheses, sine of x, end, squared. But I'm pretty sure either of those will work
It's basically the same thing.
on the calculator. Now, normally I would say that this is not the same. Because I would have said, see, on the calculator, that's the one that's different.
Okay.
Does that make,
Yeah.
That one looks awesome though.
So that's the one that's different on the calculator. Now, honestly, in real life, I would say that this one is this. If we were doing this by pen, just writing it. This is why, where do we normally put the squared?
You put it before the.
It is the same.
We normally do, now do you see why we do that? Because then you don't have to have this funky argument. Yeah. Okay, D. F of x equals natural log of x squared minus 9 on the interval -2 to 5.
Natural log is that.
There's 1 over x.
I'm not talking derivatives yet. We're checking EVT.
Oh.
Now, traditional natural log is
And over.
that. Now.
Put that.
Natural log of x squared minus 9 gets a little funkier, doesn't it? What do we know about the inside of a log?
It's 2 log b. Either added or subtracted.
Okay. But the inside of a log can never be, what kind of value can this not be? X squared minus 9 is never going to be able to be,
0.
well, 0 or negative, right? A log cannot be negative on the inside. Are there any values that are going to make this negative in this interval?
-2 and -1.
Yeah. And 0, and 1, and 2,
And that doesn't exist.
and 3.
I graphed it to see.
Okay. And so if you throw it in the graph, does my calculator, does my graph exist on the interval -2 to 5?
No.
Partially, but not all the way, right?
It's like all the way, like, you can see.
Yeah.
Fancy.
So, what do we know here?
Not to
EVT does not apply.
EVT does not apply because it is not continuous.
On the interval.
F of x is not continuous on -2 to 5. So, EVT does not apply. And I have written in mind that f of x is undefined from -3 to 3, right? I mean, that's, you know. So, kind of a side note there. And that you could have said f of x is undefined on -3 to 3, so EVT does not apply on this interval. There's lots of variations of how you could write it. Okay, so that's a no-go. E.
I'm going also with no-go. X can't be 2.
Yeah.
Why can't x be 2?
Because it'd be 0.
What?
Right? Because it's
But it's not like it's in a
Oh, and
denominator.
it's squared. And the square root of 0. L is
So it would be x minus 2.
I mean, if you do 2 minus 2, you're just going to end up you're going to get 0, but nothing says it can't be 0.
I changed my mind.
Okay. So, okay. This is a cube root function, and cube root function is the sideways version of a cubic function. Okay. Now, again, can you throw it on the calculator to double check yourself? You can. Okay. But to my knowledge, this one works. So let's talk about it. What are you thinking about derivative?
Negative 2/3. No.
No.
Yeah.
Get a one.
1.
Yeah.
No,
you are
2/3.
right. You are right.
2/3. Not
If before we take the derivative, is this what we're trying to get straightened out?
Yeah.
Before you take the derivative, what's another way to write this? X minus 2 to the 2/3. Are you with me?
Yes.
That is necessary before you can take the derivative. So now, the derivative.
2/3.
2/3,
X
x minus 2
to the negative 1/3
to negative 1/3
minus 1 times 1.
times 1 times the derivative of x minus 2, which is 1. Now, I am going to write this a little bit different
2 over 3 cube root x minus 2.
in terms of writing it as a fraction. The 2 stays on top. The 3 goes on bottom. A negative exponent moves to the denominator. You can either write it as x minus 2 to the 1/3 or the cube root of x minus 2. Okay. Now,
Cool.
when we talk about this one, we're talking about setting the derivative equal to 0 is our normal rule of thumb. What happens when we try to set our derivative equal to 0? Derivative is a fraction. When do fractions equal 0?
The numerator.
When the numerator equals 0. When is my numerator going to equal 0?
No.
It can't. So will my derivative ever equal 0?
No.
No. In this case, my derivative will never equal 0 because 2 will never be 0, right? Now, if you go back and read, what was it, bottom of the previous page, the candidates, wait, where was it? Absolute extrema, no, there we go, critical number. Look at your definition of critical number, critical value. A critical number of a function f is an x value in the domain of f such that the derivative equals 0 or does not exist. So we need to look at when does h of x not exist. And here's the deal. Because it's a fraction, is there a possibility it won't exist? Yeah. When does this not exist? At x equals 2, because that's what will make my denominator 0, and denominators can never be 0. Valid? So this happens when x equals 2. Okay? That's not a very good way to express that, but
So I was right about the x equals 2, just not.
it just wasn't relevant right then. Yeah. Okay, x and h of x.
Yeah.
What values do we need here?
1, 2.
Okay. Our critical value was 2, because that's when my derivatives not exist. Derivative never equaled 0, so that was an issue. And then 1 and 10 were my endpoints. Your y values are 1, 0, and 4.
Thanks.
What about a min?
0.
0.
What about a max?
4.
We good?
Yep.
Okay.
Now we're sorting them.
Your job for tomorrow is to get the 5-2 homework done.
Are we gonna start lesson 3?
I believe it's only 16 questions. 3 pages. Some of them are a little bit long though.